Thank you to Magic Spoon for sponsoring today's episode. Go to magicspoon.com/SciShow and use the code SciShow at checkout to get $5 off any order. Picture an animal with tusks. You're probably thinking of elephants, but maybe walruses, boars. Well, they all have one thing in common. They are all mammals. To better understand how tusks evolved, researchers publishing this week in the Proceedings of the Royal Society B studied teeth in an ancient relative of mammals. And in the process, they offered up a more definitive answer to what the heck tusks even are. To understand how mammals got their tusks, the researchers looked back in time. Back to approximately 270 million years ago, when ancestors of mammals known as dicynodonts roamed the planet. Dicynodonts came in all sizes. They had stocky bodies, short necks, big heads, turtle-like beaks, and prominent front teeth. In fact, the name dicynodont actually means two canine teeth. But one day, out in the field, the researchers behind this new study were having lunch surrounded by dicynodont teeth and wondered, why do we call these tusks when they're more like teeth? They seem to have features that tusks shouldn't technically have. The definition of a tusk is surprisingly wibbly, but it's not just any old ginormous tooth that sticks out of an animal's mouth. So the researchers proposed a clearer definition. To start with, it does need to be a protrusion from the animal's mouth cavity. It also needs to grow throughout the animal's life. A big old pointy tooth that just grows in and then stops doesn't count, because tusks are generally used for something, like fighting or digging, so the animal benefits from growing them back if they break. So the researchers defined certain features associated with continuous growth. A tusk, they said, has to be connected to the jaw by ligaments, and it has to be made of a material called dentin instead of coated in a protective layer of much harder enamel. So rodents, for example, would not qualify because their protruding teeth have some enamel. With all this in mind, researchers took a closer look at the earliest tusks we know of, dicynodont teeth. They rounded up fossils from 10 different species from museums around the world. They took very thin slices of their tusks and then imaged them in high resolution. And they found that not all of the teeth were tusks after all. Some of them had a thin cap of enamel, others were fused to the jaw rather than attached with ligaments, meaning that there was no way the tooth could be continuously growing. And prominent teeth that were not tusks were more common in earlier species of dicynodonts. But surprisingly, there was not a smooth progression from teeth to tusks overall. The researchers say this suggests that tusks evolved repeatedly in different species of dicynodonts. We know that's the case in mammals too. When it comes to why tusks evolved this way, it might be that there's a trade-off between dentin, which can grow continuously, and enamel, which is one and done. If you're using tusks as a tool, it's helpful if they can keep growing back even when the rest of your teeth can't. Rodents hit a halfway spot with a partial enamel covering that can grow back, but the researchers found that enamel-less tusks tend to evolve eventually. While animals like sharks are infamous for always having a new set of teeth in their back pocket, many mammals only get 1 or 2 sets in their lifetime. And it seems like once dicynodonts evolved fewer sets of teeth, the stage was set for them to acquire continuously growing tusks as well. While this does not tell us for sure that mammals acquired their tusks this way, the researchers think it's possible that similar evolutionary pressures led to mammalian tusks. So the more we learn about these very early tusks, the more we might eventually be able to learn about the ones that mammals have today. And the more we say the word tusks, the less it starts sounding like a word. Tusks. 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 It's gone. While we're on the topic of mammalian traits and where they came from, let's talk about something that most of us consider pretty uniquely human: music. Plenty of studies have shown that there are elements to music that are universal across human cultures. Now, in a study published this week in the journal Current Biology, researchers are showing that an endangered species of singing lemurs has one of those elements: rhythm. The lemurs in question are called indries. They live in small family groups in the rainforests of Madagascar, where they often sing coordinated duets and choruses of eerie wails. Over the course of 12 years, the researchers involved in this study recorded samples of songs from 39 indries in their natural habitat. Then they did some statistical analysis of the lemurs' haunting songs. There are lots of ways to measure time when it comes to music, like rhythm, which refers to a pattern of sounds, or tempo, which describes the speed at which they happen. In this case, the researchers were looking for a feature known as categorical rhythm. One common category of rhythm humans use is a 1-to-1 ratio, where each note is as long long as the next, like singing along with a metronome or the lub-dub of a heartbeat. Humans also use a 1:2 ratio, where some notes are twice as long as the next notes. The 1:1 ratio is the only ratio we've definitively seen in non-human species. Songbirds use it, for example, though they can sometimes approach 1:2. But when the researchers analyzed the lemurs' songs, they observed clear groupings of rhythms, and when they looked closer, they found both 1:1 ratios and 1:2 ratios. Basically, their rhythms were more human-like. But not perfectly. In humans, we tend to think of rhythm and the length of notes in relation to a measurement of time we call the beat. The researchers point out, however, that we can't necessarily assume that the lemurs have a sense of the beat. But this provides more evidence for the idea that there really are universals in music. Even though they are fellow primates, injuries are such distant relations of ours that the researchers think we probably each evolved our singing skills separately. Nonetheless, they still think the lemurs could help us understand how musicality evolved in humans. So while the injuries might not be quite ready for karaoke, they can teach us a lot about the way we make music. Know what else humans have that lemurs do not? A truly staggering amount of choice when it comes to breakfast cereal. And if you'd like an option that is tasty without overloading you with sugar, you might like Magic Spoon. You can pick the classics like cocoa and fruity and frosted and peanut butter, or if you're feeling adventurous, there's more options like cinnamon and cookies and cream and blueberry and maple waffle. Whatever you choose, Magic Spoon has 0 grams of sugar, 14 grams of protein, and only 4 net grams of carbs in each serving. It's also only 140 calories. If you're interested, you can go to magicspoon.com/SciShow to grab a variety pack and try it out today. And be sure to use the promo code SciShow at checkout to get $5 off any order.